So today we're going to be solving a UNSW integration problem from 2019, I suppose. It's going to be an integral between 0 and pi over 2 of the natural log of the tangent of x with respect to x. And don't mind my Christmas sweater, it's just a season for ugly clothing. I guess it's going to be nice, yeah? So anyway, how to evaluate this guy? So first of all, I'd like to call it some kind of an I as an abbreviation for an integral. I have no idea why people just call integrals i's, like whatever. So, well, this is one of those integrals when you just can't really brute force it. I mean, honestly, I would never ever try and solve this guy using just, I don't know, UNSW, like u equal to tangent of x and then trying to do integration by parts. It would be a mess and it would be awfully long, and I'm just too lazy of a person for that. So I'd like to show you guys a neat trick that we're gonna be using in order to evaluate it, yeah? So I would like to make myself a u substitution of x being equal to pi over 2 minus a u. And so that will mean that u is just equal to pi over 2 minus x. That will also mean that dx is equal to negative du. And as for the bounds of integration, whenever x is equal to a 0, u is equal to pi over 2 minus 0, which is pi over 2, and so pi over 2 is the lower bound. And now as x is equal, whenever x is equal to pi over 2, we'll get that u is equal to pi over 2 minus pi over 2, then just a 0, and this is our u sub. I want those two lines to be of equal length, honestly. Yeah, so this u sub is gonna transform our integral to look like this. It's going to be an integral between pi over 2 up to 0 of the natural log of, and now the tangent of pi over 2 minus a u, and that's gonna be all with respect to negative du. But now, what's the problem here? Well, first of all, we have fluid bounds of integration. I want to take the pink color, which I hate, but the nice fact is that we've got a negative sign right there. And so we can just kind of take it out of the integral and then use it in order to flip our bounds just like this. And there's also a pretty interesting trick identity here inside of this tangent, which was actually the reason I did this sum in the first place, honestly, because tangent of pi over 2 minus u, which is kind of like the tangent of 90 degrees minus a u if you're from Europe, what you get is just the cotangent of pi over 2, and so it's gonna look pi over 2, the cotangent of u, that's gonna be something like this. And so we're gonna rewrite this entire thing as just the, I'm using too many colors, honestly. It's gonna be the integral between 0 and then pi over 2 of the natural log of the cotangent of u. That's all gonna be with respect to positive du right now. But now, well, just notice one pretty important thing. This guy right there is still equal to I. This is the same integral we were evaluating before. We just kind of, made the u sub and then just changed the tangent to a cotangent through some trig identities. Nothing changed as to the value of the integral itself. So I could just add them up. I can just take my original integral, which was, and I'm gonna change colors, let's say to pink. It's gonna be the integral between 0 and pi over 2 of the natural log of the tangent of x dx, and I'd like to add it to the integral between 0 and pi over 2 of the natural log of the cotangent of u du. I can't really do it because I have different variables. I've got u here and an x here, but the nice thing is that both of those integrals are just a numerical value. I mean, both of those are definite integrals, so they're gonna just spit a value at the very end. So there is no point in just calling any of those variables u or x, I can just, well, call those variables in question whatever I wish. So I just replace the u with x. There's no problem in doing that. You can also, I don't know, just treat it like a u sub, but an inverse u sub, let's say. And now I'd like to add those guys up together, and so I will get that, well, also provided that they are both equal to I, which I know is true, I will get that double my I is equal to, and now we can just sum those integrals up, the integral from 0 up to pi over 2 of the natural log of the tangent of x plus the natural log of the cotangent of x. That's all gonna be dx. But the nice thing is that whenever we have two logs added together, let's say I'm gonna write in green or something like this, the natural log of a, and then we add a natural log of b to it, that's the same as just saying the natural log of a multiplied by a b. And so we can just say, we can combine those two natural logs in the integrand to make this integral be just an integral of the natural log of, and I'm just gonna, some kind of different color in order to differentiate all of that stuff, of tangent times the cotangent of x. That's all gonna be dx. But the nice thing is that, well, this tangent of x right over there, this thing is just sine of x divided by cosine of x, but this cotangent, that's just cosine of x divided by sine of x. And so what we'll get is that when we multiply those two together, what we'll get is just a plain old 1. And so this entire integral will just become an integral between 0 and pi over 2 of the natural log of 1 dx, but the natural log of 1 is just a 0, and so we are actually integrating a 0 in a definite integral, and so we will get that is equal to a 0. But if 2 times our integral right here is equal to a 0 right there, then we've got that our integral itself, which is I, was equal to 0 in the first place. Hope you guys enjoyed it and see you in the next one. Bye.